Welcome to this edition of the Retrieval Markets Demo Day. Today's date is Wednesday, the 23rd of November, 2022. Happy Thanksgiving tomorrow to our American colleagues. Today we've got two very exciting talks. We've got Colin Kennedy from Magmo speaking about some ideas he's had for the Go Nitro Magmo work. And then we have Alex Camuto, Protocol Labs, talking about Quarry, a new data availability tool. Over to you, Colin.
All right, thank you. Let's see if I can share a screen. How is that? I'm seeing a presentation.
Looks good.
Okay, yeah, so I mentioned I'm Colin Kennedy, Team Magmo, and I'm presenting some, it's kind of slightly contrary to the spirit of a demo day. This is the opposite of a demo. These are slightly far-flung ideas, but they're ideas that are applicable to the retrieval market working group, I think. So yeah, possible futures for state channel networks. And this is very much an outsourcing presentation. We have a lot of loose threads that we could pull on. What seems interesting to people in the call or people who watch this in the future, please be in touch. So I will give a very brief intro to the protocol. Most of the people present right now are pretty familiar, but just kind of due diligence for anyone who stumbles across this. And then I will talk about 3 research questions, which will get more speculative as we go. And with respect to the preliminaries, I'll point out that 2 of my teammates recently gave very good talks at the Retrieval Market Summit in Lisbon. These talks are now available on YouTube. There are links in the Filecoin Slack channel, Retrieval Markets. But I think if you just search for these titles, you should find them on YouTube, and they will give a good overview of what we're building and recent progress and all of that. So diagrams in this presentation will have basically 4 elements. There's a blockchain, a contract, which has rounded corners. Channels are circles, and arrows are funding commitments. And a funding commitment basically means that the thing being pointed from has funds that are specifically addressed to the thing being pointed to. So yeah, what is a channel? Say Alice and Irene want high-speed, low-cost transactions. They would like to make a channel. They use a channel to do that. They perform a handshake to spin up a unique address. They agree on the initial balances of the channel, and they apply digital signatures to all of this information. Then they fund the channel by making a deposit on a blockchain specifically addressed to that channel. And these funds are managed by a smart contract. Now they can interact inside of this channel totally off chain and eventually come back and settle it when they're done. What is a channel network? Well, we just kind of throw this situation, say Irene and Bob have a channel via the same means above, but now imagine that Alice and Bob want to transact. They have better options now than funding on chain. They can use their existing channels and their relationship with the common intermediary Irene. And this is now 100% off-chain operation. They spin up this channel very quickly, very, very cheaply, and they can then interact inside of the channel with high throughput. So that's it for preliminaries. You're basically caught up on state channel networks as that's the state of the art. So the first idea that we're going to talk about today is optimistic seed funding for virtual channels. And this is really something that is focused on user experience for clients in a retrieval market setting. So currently, clients make on-chain deposits with hubs. So apologies, I'm going to use like hub and intermediary somewhat interchangeably. Irene in this diagram is a hub for the network. Alice has a channel with Irene on chain. Bob has a channel with Irene on chain. And the Alice Bob virtual channel, which is kind of like the business channel of a retrieval market, that gets created on demand. But what could be done instead is that these channels could be created proactively. And you would do this to drive down average time to first payment. So with existing Filecoin payment channels, the time to first payment is quite slow. It's on the order of the Filecoin block time. With on-demand virtual channels, the time to first payment is hovering around 100 milliseconds right now. Alex's talk in particular goes into detail about how we are measuring and benchmarking that number. But with an optimistic seeding network, the average time to first payment could look something like 10 milliseconds. And that 10 millisecond average is populated by a whole bunch of zeros and the occasional 100 millisecond of the on-demand virtual channel. So how do we do this? It's kind of made possible by expected market forces and the power law that applies to networked services on the internet in general. So in a mature retrieval market, we expect popular content to be densely served everywhere. Highly localized content should be densely served in their local markets. And the power law says that most of your retrieved content will actually come from a small number of providers. And in particular, like the providers who are closest to you are aiming to serve you most of your content. So if, with some made up numbers, if 90% of your retrievals come from fewer than 100 specific providers, then optimistic seed funding of channels, like keeping a channel warm for those providers, provides a very good trade-off. And you get very fast service, fast trustless service from those retrieval providers. The reason why you don't want to do this, kind of the opposite side of this trade-off space, is that when you have a whole lot of channels, there are limits to how much data can be crammed into one channel. So to get around those limits, you have to use recursion in your ledger funding. Your channel that is funded on chain has to fund a bunch of other channels, which fund a bunch of other channels. And this is bad enough for a retrieval client, but on the provider side, we sort of are building for a future where there are many, 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 many retrieval clients. You know, talking like devices on the internet. The number of channels that you're expecting to manage here could grow to the size that like you can't actually store the data in memory or on device. So this is the trade-off. So initiative number 2 is kind of a multi-route or a cross-chain state channel network. So what is that? Currently, our intermediary Irene brokers transactions that are anchored by a singleton smart contract, but she could potentially instead broker transactions that are anchored by multiple smart contracts on multiple blockchains. And we'll kind of zoom into the security model a little bit to explain how that works. So currently, Alice and Bob open up the virtual channel, and it's taken for granted that there's a publicly viewable route to all of this funding, and it's the blockchain. But really, I mean, it's specifically in our Nitro adjudicator smart contract that lives on chain. Nitro is the name of our protocol, if I haven't said so. And it has custody of these funds. But really, inside of that contract, it indexes all of these funds for specific channels. And we've made a lot of effort over the years to build a lot of confidence that this Alice Bob virtual channel is secure for all participants. But the security path for each participant is actually unique. So imagine that Alice and Bob are in this channel, and then Bob Bob's computer catches fire, and Alice wants to recover some sizable amount of funds that are in the channel, but she can't do it collaboratively with Bob. The way this works is that Alice takes statements from the Alice Bob virtual channel. She takes statements from her ledger channel, brings both of these back to the blockchain, the adjudicator contract, and says, hey, I have these running channels. I am owed this much. The adjudicator reads these statements and pays out in a way that is fair according to those statements, and in particular fair to Alice. So this is Alice's security path on the channel, and Bob has a similar security path, but it goes back through his channel. Notable is that Alice does not care. She does not have a vested interest in the funds that are allocated to channel ABC here, the Bob Ledger channel. She cares so little about it that those funds could be somewhere else entirely, say in a different adjudicator contract. We have adjudicators 1 and 2, and those different adjudicators can live on different chains, or they can live on different subnets in the style of Filecoin's hierarchical consensus roadmap. This hierarchical consensus roadmap is actually what sort of prodded us into looking more closely at this possibility. We have had this idea, or at least the seed of this idea, for at least a year, according to some old Notion documents, but it sort of came back to the front burner when we were in Lisbon and learned about the hierarchical consensus roadmap. So the key protocol modification that makes all of this possible is adding a little more detail in the accounting of channel balances. Previously, the accounting essentially labels assets and declares where those assets are pointed to, who has what balance. But now we add a full qualification for those assets, not only where those balances are owed, but where we expect those balances to be coming from. And this lets us label assets that should live at different funding routes for the network. This lets us set up an exchange of asset channel. So here in this channel between Alice and Bob, Alice can pay in ETH or whatever ERC20 she has used to fund the Alice Irene channel. Bob is paid in FIL or whatever FEM ERC20-ish coin that exists in the FEM future. And this is really abstracted away for each participant. The security in the Alice Bob channel is denominated in their native asset for each participant. So if things go wrong, Alice still takes that same path. She takes it back to the Ethereum blockchain. If things go wrong for Bob, he takes his security path back to the Filecoin chain. Neither participant particularly cares about what asset the other person is denominated with. At a certain level, their Nitro client software knows, but they don't know or care. An exchange rate is kind of determined at runtime when you spin up the channel. You set an exchange rate between the assets, and Irene services this exchange very much the same way that she services existing virtual channels. So consequence here is that these channels can exist on any number of EVM compatible runtimes, including like Arbitrum here, that is a rollup on top of Ethereum, but there's no reason it couldn't have an adjudicator that is managing funds. And Alice, Bob, Carol, and Dave here all have channels with Irene, and any pairwise couple from that set can spin up a virtual channel through Irene where they pay in their preferred asset and are paid in their preferred asset. And kind of similar, like the intermediary just services the exchange, sees an increase in one asset and a decrease in the other in a way that is deemed fair at runtime. So our kind of research focuses on the establishment of channelized applications with like this high throughput. But it's also notable that Nitro can also do just like a vanilla payment. So this sort of network would also serve as a backbone for like universal cross-chain L2 payments, point of sale payments. There's no reason why your coffee shop who wants to get paid in, I don't know, ETH on Arbitrum can't present you with a QR code that lets you in network create a payment for them with fast settlement, like 3 seconds, serviced by these intermediaries in the network. So yeah, I mean that's that. And the last idea is around activating the latent collateral in a network. So this is really about capital efficiency and the macroeconomic picture in a network. This is sort of maybe the most exciting in the bunch, but it's also the most subtle and abstract. So apologies. But describing the background for the problem or like this issue, talk about two problems inside of state channel networks as currently conceived. And problem is maybe too strong a word. It's just sort of like, these are things that happen as a result, like in the trade-off space for getting the nice things about state channel networks. The security guarantees in these networks are capitally intense. We've talked about it already. Each participant in the virtual channel needs a path back to an adjudicator which is fully funded. When Bob ghosts here, Alice takes her path back. If Alice ghosts, then Bob needs to take his path back. But essentially that means that the channel itself is doubly funded. And that's in the best case scenario. If you're going across multiple intermediaries, that funding multiplier increases. So that's problem number one, capital intense security. Capital two is dormant capital inside of ledger channels. So say that you are a client in a retrieval market and you deposit $50 to consume content, but you spend about $1 a day. You've got this substantial balance sitting there that is mostly idle. And in the cryptocurrency space in general, we don't love idle balances. We'd like our networked capital to be active. And if you look at both of these problems at the same time, the network takes too much capital for security and the network has too much capital lying around, it screams opportunity. If Alice's deposit here can be used in a secure way to provide for the capital requirements of the security guarantees, then Alice would have a chance to participate in the earnings of the network. So the sort of the approach to this is to notice that the capital in ledger channels is doing at least two things, but I think it's doing these two things which are slightly distinct. It is providing runtime security for virtual channels, and runtime security here means like being there on that challenge path. If something goes wrong in Alice Bob, then Alice and Bob can use their ledger channels to recover those funds at runtime. But the other thing that the ledger channels do is that they do the accounting for all of Alice's total spend in the network, and they do the accounting for all of Bob's total earnings in the network. So it's doing both of those things at the same time. If these responsibilities can be separated, then I think there are gains, and maybe they can be separated. The important idea is to make assumptions about different participants being either spenders or earners in the network. And the nice thing about an earner is that an earner's balance only goes up over time. And balances that are kind of monotonically increasing like this can be safely recorded by a voucher structure, which is less complicated than a general channel outcome. But it can also be decoupled from individual channels. So let's build out this network. Spender Alice deposits into the network, and then she uses some of her dormant collateral to virtually fund a ledger channel for some earner, Bob. Now, Bob is going to use this channel as he normally would, for example, to fund a channel with Carol. But what about these two jobs of ledger capital? So runtime security is unchanged for Carol. She takes the same path back to chain, and it's really no different. It's slightly modified, but still present for Bob. There's not a lot of difference. The rules of the Alice Irene ledger channel would have to be modified such that Bob has some challenging rights, but this is not very difficult. And the other job of earnings accounting, in the status quo Go Nitro network, closing the Bob Carol virtual channel causes those balances to bubble up to the two channels that funded it. That works the same here for Carol. The closure of Bob Carol bubbles up and causes an adjustment in the Carol Irene ledger channel. But the Bob Irene virtual ledger channel, it's important to note that like neither Bob nor Irene actually own that money. That is Alice's money. So instead of having that balance bubble up to the channel, Bob collects vouchers which are payable by Irene at the closure of Bob Carol. And Irene's debts here that she's accruing to Bob, they're offset by her earnings on the other side in the Carol Irene channel, so she's happy to participate. So this is a rough sketch. This is kind of like early stages for this idea, and work is ongoing to make it sort of robust and zero trust to somewhere between trust minimized and zero trust, with well-defined time to cash out for earners in the network. The consequences of this are much better capital efficiency in the network. Previously, only the hubs who are servicing this capital would earn interest, and client money would sit idle. With active collateral, clients depositing into the network to consume services would earn interest on their deposits. And it also really drastically lowers the capital requirements for hubs to participate in the network, because they aren't fronting all of the money for all of the transactions. The money comes from consumers. So wrapping up, talked about three initiatives. There's optimistic seed funding, which will definitely work, but the impacts are really hard to estimate based on like how much of your content is coming from a small number of providers. So the impact is really hard to guess. The impact could be really, really poor under certain network topologies, but it'll work. The cross-chain Nitro, that we've talked about this in some detail, like now, and we're pretty sure that it's workable. Potential impact is that service providers have access to a bigger variety of capital networks that could join the network and pay for stuff, and as a potential like a universal cross-chain payment L2 for EVM compatible blockchains. And active collateral, this is still kind of speculative. There are holes in this idea still, but it should, as an impact, it should definitely lower the overall network fees by, I would, very rough guess, but at least 30%. And the bigger impact is that sort of macroeconomic picture of the network is that end users share in the network profits, which is a pretty happy place to be for a decentralized service network. And that's it. So thanks. Happy to have questions. But you can check out us at magmo.com, email research@magmo.com, or otherwise talk with people in the retrieval market.
Awesome. Thanks, Colin. That was super interesting. Any quick questions?
I think there was a question in the chat, which would be good to get Colin to quickly answer if he's up for that. So this would be, was your question, Patrick? Does Irene care if she's losing FIL for ETH?
My question was a bit of a joke because I thought she wouldn't want to give up her lovely Filecoin for Ethereum. But yeah, no, I think that's really interesting. The idea that it becomes sort of like a market of, and you can, you can just have the exchange between those assets happen.
Yeah. So I mean,
between different chains.
A comment on that is that like the exchange rate on those assets is determined at runtime at each channel creation, but the person servicing the exchange isn't trying to make money from you on the exchange itself, because they are the people who actually swap assets, right? Like Irene gains ETH on one side and loses FIL on the other side. So like the intermediaries in that network aren't looking to make money on the actual exchange rate, because like they are the bearers of the exchange rate. So yeah, that's
okay, great, thanks.
If she hates changing one thing for another thing, then she can just like slope the exchange rates in that direction.
Gotcha. Okay, Walker had a question. Walker, do you want to say it out loud?
Hey, I think George answered it. I was just thinking out loud that these channels might be somewhat short-lived, such that Irene has the chance to rebalance if necessary. And the exchange rate would be set up such a way that, yeah, she's not exposed to the risk so much of differences between the assets.
Yeah, so I mean, anytime you, I guess, set an exchange rate and then commit to it, you have like a slippage risk, right? If you find one of these channels and then like there's a video of Vitalik strangling a puppy, then like ETH could drop off a cliff. But no, I mean, in the retrieval market in particular, like a lot of these channels kind of expect to be pretty short-lived. So I think that insulates you. But that's a calculation that people would have to do for themselves, I guess. Like how much capital over what sort of time frame are you willing to commit to a certain exchange rate at? But the other thing is that this risk isn't actually borne by the intermediary, is it? Yeah, it is. It's borne by, that risk is borne by all parties in the channel, I think. Yeah, so generally, like those virtual channels, we expect them to mostly be fairly short-lived, I think is the main answer to that question.
Nice. Okay, well, thank you very much. And I think we'll move on now, just in the interest of time, to Alex, who's going to talk about Quarry.
All right, let me share my screen. Can everybody see that? All right, I'm going to assume you can. So I am going to be introducing Quarry, which is the project Thomas and I have started working on since we joined Protocol Labs after being at Mile. So for those of you who don't know, we've been working on the retrieval markets problem for quite a long time, almost 2 years. And it's a particularly thorny problem if you are trying to design a broad-based retrieval market for all kinds of data. And there's a whole host of reasons for why that is. But after 2 years, we decided to really go back to basics and ask the question as to what data is most in demand within the decentralized web or within blockchains, but is somewhat difficult to access for clients that want to fetch this content. And the answer we came to was a blockchain state. So the global state in the case of Filecoin, it's called the world state in the case of Ethereum. So that might be the balance of a specific account. It could be the state of a variable on a smart contract or a Filecoin actor. And there's a whole host of reasons we might want to fetch that state. It powers, it might be the percentage of yield you're getting on some DeFi smart contract. And you want to be able to know what that yield is before you make a decision as to whether you want to put your money in a liquidity pool. So who currently sort of ingests that state? Browser clients or browser wallets like MetaMask need that state, or certain web applications like dApps currently need to feed that state to users. Mobile wallets need that state to be able to issue transactions correctly or interact with dApps as well. But also other chains and smart contracts on other chains might want to know the state of another chain. Like, for example, if you're building a bridge between two chains, one smart contract might need to know the state of a smart contract on another chain so they can bridge assets correctly. And so the commonalities between these consumers of state is that they're typically really resource constrained. If you're a smart contract, you're in an extremely resource constrained environment. Operations are very expensive, and this is sort of similar to this also applies to browsers and mobile wallets. So you can't really sync the full chain to be able to get an up-to-date and trustless view of the state that you want to ingest. And you're sort of siloed from the blockchain network as well, because you might not have, the networking protocols that full nodes run. And so what are the current solutions to this problem? As I'm sure most of us interact with dApps using centralized service providers. So Infura or other hosted services will run a full node for you, and your wallet will connect via HTTP or RPC to that node to get the latest state, and you're sort of trusting that service provider is delivering you, the latest and greatest state that you should be acting on. And in terms of communications between chains, we have centralized bridges using multi-sigs or HTTP oracles that are sort of relaying state between two chains. So what are the problems with these sorts of approaches? Well, the issue primarily in the case of the hosted full nodes is that if Infura, for example, goes down, you're not going to be able to interact with most of the applications that you know and love. MetaMask has famously had issues as soon as Infura has gone down. You're not able to dispatch transactions or issue or access your funds. And similarly, there have been a whole host of issues, in centralized bridge architectures. We've lost $1.3 billion to hacks this year, sometimes because there's only one or two oracles that are surveilling, the state between the bridges and relaying it, sometimes because, funds within a bridge are controlled by a single multi-sig. So really what we're trying to do with Quarry is we're trying to design effectively a retrieval protocol, which enables light clients, whether they're in the browser or they're in a smart contract, to succinctly sync Filecoin block headers and to trustlessly retrieve the state associated with that block header. And so what are some of the design constraints we've given ourselves? So we want like clients to be able to succinctly verify the integrity of Filecoin block headers. We want them to also be able to determine that the state they're retrieving matches that pointed to by the latest header they've just received. In the case of browsers, we want them to be able to broadcast new transactions to the network without a hosted intermediary. Clients should be able to receive all of this directly from what we're calling Quarry retrieval nodes, and Quarry nodes in turn should be compensated for delivering these block headers and for delivering the state. And we don't want to place an undue burden on Quarry nodes, for example, to have authority issued certificates or to have public IPs. And so I guess the broader question is, how is this a retrieval market? Well, if you think about the design of the problem and the constraints of it, it's really just a retrieval market where we're very opinionated as to the data that the nodes are delivering and serving. So it's one where the market and where the data is blockchain state. It still requires trustless and performant data exchange between peers in a peer-to-peer fashion. Our network is going to be built on browser-to-browser or browser-to-server peer-to-peer transports, much in the same way. It's still going to require peer discovery in a decentralized fashion, and we're still going to need to design incentive mechanisms to compensate Quarry nodes for delivering content. So it's very similar to the retrieval market setup. We're just reducing the problem to one where the data that we're serving is one that we know is currently high in demand. So why do this now? Or why is this a good time to build this? Well, the networking stack within the Protocol Labs and Filecoin ecosystem is one of the best in the peer-to-peer space. And recently, libp2p has made leaps and bounds in terms of designing transports which enable browsers to connect directly to servers without requiring authority issued certificates. Things like web transport and WebRTC sort of fall into that category. There's also the launch of the FEM, which means there's going to be a whole new slew of really valuable state that's going to be generated by the Filecoin network, which people are going to want to access, whether that's browser clients or other chains. And also in the past 2 years, there's been leaps and bounds of improvements in cryptographic methods, which can help us with the succinct verification of some of these block headers that we're receiving. So in terms of the roadmap of the project, currently we're focused on the alpha, which is just a browser client that can directly fetch state from Filecoin full nodes. It can also issue messages directly to those full nodes and get those included in the message pool. For the beta, we're going to be working on a succinct verification protocol so that clients, whether they are in the browser or they're a smart contract, can succinctly verify block integrity or a state that they receive. The next version, we're going to be focusing on the design of incentives to reward Quarry nodes for providing the service. And finally, we're going to be looking to integrate into compatible browsers like Brave, or directly into browsers that support wallets like MetaMask as part of our first release and proof of concept. So it's still early days, but if you want to check out the project, we have a GitHub repo where we've got some preliminary explorations towards delivering this. So if you want to take a look, check it out, or if you want to contribute, also feel free to reach out. I'm sure there's going to be some more talks where I'll have the opportunity to dive into like the design of this a bit more, but I just wanted to provide sort of like a high level overview of the project and some of the motivations that underpins it. And that's it really.
Nice, thanks, Alex. Any questions? I might just ask one quickly, just to clarify. Could you just explain why it's called DAS Quarry?
Yeah. Well, okay, so the problem is very related to data availability sampling, which is a sort of adjacent problem of making blockchain state widely available, and blockchain headers widely available to nodes. And that's why the project is called DAS Quarry. is DAS
Nice.
is the
Thank you.
acronym for data availability sampling.
Did I hear someone else with a question?
I had a related question about Quarry. Like,
Okay.
why Quarry? Is that like where miners go to work or something? Like, what's the thinking behind Quarry?
Oh yeah, exactly. Well,
Right.
yeah, and yeah, exactly. We kind of wanted to lead more into the mining side of things. You know, there's a
Okay.
lot of space imagery, but we wanna keep it down to earth, you know.
Yeah. It's super exciting. Yeah, I think it's great. I don't have any questions, but I think it's great.
Awesome.
Yeah, I think particularly with the amount of blockchain state that's going to start to emerge with FVM, this is a really exciting project. Nice. Any other questions? All right. Thanks everyone for joining. I will upload onto YouTube and let you know when I do. And have a great rest of your day.